Alright, this is a quick video to demonstrate how we're able to measure a range of different values of signals more accurately with our USB oscilloscope. So here's the oscilloscope, and connected to it, it has a 10x attenuating scope probe connected to our function generator, which right now is generating a 2 volt, 2 kilohertz sine wave. And before we amplify it back up, rather it gets attenuated down before it goes into the oscilloscope, and before amplification it looks very small on the screen. There's a lot of noise in it too. We only have an 8-bit ADC. And we can compensate by having programmable gain amplifiers inside amplify the signal back up. We'll also amplify noise with it. So this is sort of a compromise between being able to measure very small signals and while simultaneously being safely being able to measure large ones as well. We have another solution in that when we disconnect the probe, we can connect a standard BNC cable. I'm going to put the... There we go. We can take a standard BNC cable and plug it directly in. Normally we would switch over the scope to allow for BNC cables to be used, but if we leave it on the same setting, we go over here and we select our NoSeatbelts mode without the programmable gain amplification. Oh, we're clipping really badly. It is still able now to measure that signal. It doesn't get attenuated down 10 times by the 10x scope probes. So now we should be able to get a much cleaner measurement of the same signal. Granted, if you apply 100 volts right now, you may well fry the system, but if you're comfortable with taking that risk and you know you're not going to be doing anything like that, this is a good way to measure small signals with less noise and less PGA gain.